So this one is, if I've got it correct, this is the election story. Is that correct?
Yeah.
Okay, so you can tell me what numbers you've got. So in an election, how many of the voters were Republican?
The possibility of A was 0.64.
Okay.
The opposite of
0.64.
A was 0.36.
Okay, so the probability that, what do they call it, non-Republican? That's 0.36, okay.
And
what? I guess I should call that the complement. Yes.
Was 0.6.
Well, the Republican. Okay, so let's say
a voter for the X.
Right. So they then go say of the Republicans who voted, what percentage? 0.6 voted for candidate X. Got it. And
then last one I lost.
Okay, and the non-Republicans, 10% of the non-Republicans, and 10% voted for X. Okay. Wow, we got a lot of information going on here. A is voted Republican, and B is voted for candidate X. So that's what B is, candidate X. Okay, so did you get any of the probabilities, or you're not sure what any of them are? Where do you want me to start?
I want to ask the last possibility for A part, find the value for the last one.
So is this question E?
The question A part, the last one.
Oh, A part, last one, right? So in question A, the probability of B given A of C, right? So let's try and put that into English. What's the probability that you voted for candidate X given AC, that you're not Republican? Okay. So you're not a Republican, and the probability
was 0.6.
Well, the Republicans, it was 0.6, right? But for the non-Republicans, it looks like it was the 0.1.
36. Yeah.
Yes, that's it. It's that piece of information there. Of people who are not Republicans, right? Which is what you're looking at.
So B side is for the vote for the candidate X.
Yeah.
Okay. So that means.
What's the probability that you voted for candidate X given that you were not a Republican?
Oh, I see.
And that is just this number here, which they told you in the intro to the story.
Oh, I see. So what's the C part?
So we're now going to find for question C the probability AC, so that's not a Republican, right? And B, there's B, and B is you voted for candidate X. So let's put that into English. So what's the probability that you're not a Republican and
is 0.036?
I don't know, it might be. And voted for candidate X. So if I asked you to find the probability of A and B, there's a theorem called Bayes' theorem, which allows us to do these. And
The
it's
rule
good.
3, right?
Say again?
The rule 3, multiplication rules for the end.
Yes, I believe so. So the probability that you have A complement and B, you can find that by getting the probability of B given A complement multiplied by the probability A complement divided by the probability of B. So this is called Bayes' theorem. And if I build a little table, and I put Republican, which is A, and not Republican, which is B, and I do voted for X, and I guess not voted for X. We could fill in some of this information. So, oh God, I just saw the time. Okay, let's see if we can do this. I put some totals in as well. Another color. Don't have any others. Yeah, orange will try. So, if I start here and build a tree diagram, the first thing we're going to do is A, Republican, or not Republican. And a Republican is 0.64, and a non-Republican is 0.36. And here I'll put in voted for X and not voted for X, voted for X and not voted for X. Now, what do we know? If you're a Republican, so that's A, right? This fella here. What's the probability? They told us somewhere. Did I write the number down? What's the probability that you voted for candidate X given you were a Republican? What was that number?
0.6.
Okay, so you didn't vote for them, it would be 0.4. Now, what about for the non-Republicans? What percentage of them was it? 0.1?
Yes.
And so the ones who didn't vote were 0.9.
Yes.
So I'm creating this tree diagram, then I'm going to fill this guy in. So essentially, to get the 4 answers that are going to go here, 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 and here, we just multiply the pathways together. So 0.64 times 0.6, that's 0.384. 0.64 times 0.4 gets me 0.256. This guy gets me 0.036. And the last one is 0.36 times 0.9. And I have got 0.324. And I can now actually get my answer without Using Bayes' theorem? Well, actually, I am using it, but the calculations are done inside the tree diagram, so you can't see them. So what's the probability that it's an AC and you voted for X? And the answer is 0.036.
So 0.036, right?
Yeah, 0.036. 0.036. I don't even need that table now. It's enough to do this fellow. So the probability that it's AC followed by B is AC followed by B. And that comes out as 0.036. Do you want to check it out? See if we get a green check mark.
So what's the answer for B part? So that will be just add the question answer C and B together.
Yep. So if you add the answer to B, whoa, it's a lot of background sound. If you add the answer to B and C together, you will get D.
0.744.
I'll take your word for it. I don't have the numbers in front of me.
So the percentage just use the last one, just use the percentage, express the 0.744.
Yeah, so you just take the answer to D, which is a decimal, and multiply it by 100, and that will give you the answer as a percentage.